Before we jump into the declaration, it is more pronounced and persuasive to determine the subatomic gas pedals. The Large Hadron Collider LHC, operated by a 17-mile ring of superconducting magnets, is the most prominent and important particle smasher in the world. It is a symbol of the zenith of human achievement. In actuality, because it is so potent, it might replicate the exact conditions of the first second of the universe. Could an unlocking device be used? The key to the universe's secrets is something truly exceptional. Constructed in 1954, CERN is regarded as one of the most reputable research establishments with 23 member states and numerous scientists. It serves as a meeting place for innovation. The LHC is CERN's primary endeavor, but it is just one piece of an extensive system of accelerators and experiments. Think of it as a racetrack not for engines or people, but for subatomic particles. During a speed test, the LHC accelerates protons, sending them nearly at the speed of light on a collision course that mimics the energy conditions of the universe just after the Big Bang. The resulting impacts produce temperatures much higher than those at the Sun's center. Protons are guided by magnets on their journey, while intricate cooling systems keep the magnets at temperatures colder than space. In the LHC, proton beams collide at 4 points around the accelerator ring corresponding to 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring various aspects of particle physics. Together, they act as massive cameras that capture images of these collisions. Scientists then sort through the subsequent particles, looking for evidence of the elusive Higgs boson, called the God particle, and other phenomena that could shed light on the fundamental structure of the universe. By concentrating on the microcosm, we learn more about the macrocosm. Right now, with every answer comes a new question, and with each new discovery, a challenge arises. The LHC isn't just a scientific tool, it's a testament to human curiosity and advancement. It represents our need for comprehension and desire to grasp the fundamental forces that shape the universe. However, as we push the limits of what we know, we must also consider the deeper, existential concerns that arise, including the dangers of probing the unknown. Could our pursuit of knowledge inadvertently unleash forces within CERN's sacred spaces? Spaces where the boundaries of human knowledge are constantly tested. A revelation has left even seasoned scientists uneasy. Brian Cox, a former scientist at CERN and an important figure in particle physics, recently issued a statement that combines fascination and unease. His words have a chilling clarity. The purpose of the Large Hadron Collider is to recreate the Big Bang. Yes, it sounded right, a miniature version of the very event that gave birth to our universe. The physicist further explained the repercussions of this objective, highlighting the LHC's extraordinary potential for groundbreaking discoveries. This includes its ability to unlock the secrets of the Higgs boson and dark matter, a mysterious substance occupying a sizable portion of the universe. Imagine harnessing the power of creation itself, the ability to summon the very essence of the universe. It is a tantalizing possibility, but one fraught with risk. The miniature Big Bang isn't merely a theoretical idea, it is a very real phenomenon within the LHC. The temperatures, pressures, and raw energy involved replicate the circumstances of the universe's beginning, like standing at the dawn of history, witnessing the beginning of existence itself. Yet, with such power comes responsibility and concern about what would happen if something went wrong. In 1978, Russian physicist Anatoli Bugorski had a life-altering incident while employed at the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia. His head accidentally entered the direct path of a proton beam. Unimaginable energy entered the side of his head and exited through his nose. Bugorski claimed to have seen a flash brighter than 1,000 suns but felt no immediate pain. The beam's path burned a trail of destruction through tissue and bone. Despite this, he remained conscious and even walked to the medical treatment center. The aftermath was both disturbing and bizarre. The beam caused tissue damage, resulting in partial hearing loss in one ear and facial paralysis. Remarkably, Bugorski's cognitive abilities remained intact, and he continued to work as a scientist. This incident serves as a reminder of the immense energy and potential dangers associated with particle accelerators. The dangers of an instrument like the LHC should not be underestimated. Concerns about catastrophic reactions and changes in the fundamental structure of life are not mere science fiction, but real suggestions made by well-known scientists. One of the most alarming issues surrounding the LHC experiments is the possibility of creating tiny black holes, areas of space where gravity is so strong that not even light can escape. They are enormous vacuums that consume stars and enigmatic entities lurking in the shadows of our universe. The idea that the LHC might produce one of these phenomena, even on a modest scale, inspires both awe and concern. Could such a black hole expand, devouring the planet without restraint? CERN scientists have assured the public that any black hole would be unstable and vanish almost instantaneously. Nevertheless, the remote possibility has sparked debates, fears, and a sense of awe regarding our power to wield such forces. To understand how the LHC could create a black hole, consider the fundamental mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy released is immense, so immense that it can mimic the energy density present during the universe's earliest moments. This concentrated energy in a very small volume results in circumstances where theoretical predictions point to a tiny black hole. However, such black holes are unlikely to form, and Hawking's radiation theory suggests they would evaporate almost instantaneously, releasing energy and particles as they disintegrate. This theoretical safety net provides reassurance to many scientists, yet it continues to be a topic of debate in the physics community. Despite reassurances, the mere idea of creating black holes or probing such extreme realms of physics is a double-edged sword. It speaks to humanity's insatiable curiosity and drive to understand the universe, but it also demands that we confront uneasy inquiries regarding the ethical consequences of such tests. If the LHC has the potential to create phenomena capable of changing the fabric of spacetime itself, what safeguards should be in place to ensure our pursuit of knowledge does not exceed its boundaries? Can we accelerate particles to near-light speeds and recreate the conditions of the early universe without pushing the limits too far? As with all progress, the pursuit of knowledge comes with risks. Despite scientific advancements, these risks must be carefully considered and safety measures must be taken. The story of the LHC is not just about the unending investigation into our place in the universe. It is about the responsibility we carry as we push the boundaries of scientific exploration. As we attempt to unlock the mysteries of the cosmos, we must remember that great power comes with great responsibility. The effects of these discoveries could alter our perception of everything from the tiniest particles to the vast expanse of the universe itself. Scientists at CERN remain vigilant, maintaining diligence and extensive safety protocols despite their affiliation with the LHC. Uncertainty surrounds the Large Hadron Collider LHC, which is a device for innovative research, but it also represents an opening that could lead to mysterious phenomena. The enticement of the unknown, combined with the mysterious nature of quantum physics, ensures these concepts will continue to capture the public's mind. We ought to be concerned about the potential dangers of the LHC. It's easy to be swept away by sensational headlines and fears of world calamity, but the CERN researchers are well aware of the potential dangers. They've done everything in their power to ensure the safety of their experiments and keep an eye on and test their work with the greatest care. The potential benefits of their breakthroughs in research, our understanding of the universe, new particles, and the discovery of research into dark matter are truly remarkable. The Large Hadron Collider represents the cutting edge of scientific inquiry at the intersection of theoretical physics and real-world experimentation. Its true potential to respond to fundamental inquiries regarding the universe, including the origins of mass and the nature of dark matter, is enormous. Despite complete safety, extensive simulations, and measurements, the LHC still inspires a sense of mystery and some fear. The sheer magnitude of the machine and the energy it produces are staggering, and each new experiment opens up strange scientific territories. While most scientists remain confident in the safety of LHC experiments, significant unpredictability remains. What if there are unexpected anomalies that challenge our understanding of physics and the universe-wide laws? The LHC stretches the limits of human knowledge and pushes the boundaries of what we can control in the natural world. As collisions between particles reproduce conditions that have been hidden since the Big Bang, the significance of these experiments expands, raising existential questions about the potential impacts of changing the very nature of the universe itself. As the LHC continues to explore, it invites us into uncharted realms of physics, prompting us to question not only the nature of the universe but our place within it. If the experiments currently being carried out uncover profound secrets about the fundamental forces that regulate the universe, these discoveries may challenge preconceived notions. They could change our perception of everything, from the tiniest of particles to the vast expanse of the universe itself. However, with such powerful tools, scientists have what they need. They are aware of the responsibility that comes with pushing the boundaries of knowledge. The LHC's capabilities make it one of the most cutting-edge instruments ever produced, capable of simulating conditions similar to those just moments after the Big Bang. This allows for a more in-depth study of quantum mechanics, key to the Higgs boson and dark matter. The LHC were to unlock new dimensions or create unidentified phenomena, what broader consequences might arise? Could our pursuit of knowledge inadvertently lead to unanticipated dangers that alter the balance of nature or trigger catastrophic events? These are not questions that can be answered easily, and the answers may remain elusive for quite some time. The scientific community remains cautious but also optimistic. The potential rewards of the LHC's research far outweigh the risks. We are standing at the precipice of a new era in physics when the mystery surrounding the universe may begin to lift. The LHC is a beacon of human curiosity and ambition, demonstrating our desire to comprehend the universe at its most fundamental level. In the end, the LHC is more than just a tool. It's a symbol of scientific discovery and human endeavor. It represents our collective motivation to move beyond the known, to seek answers to questions that have long left us wondering. Whether it's unlocking the secrets of dark matter, gaining new perspectives, or simply enhancing our knowledge of the universe, the LHC serves as a reminder that humanity's quest for knowledge, despite the dangers, is an essential part of our development. As we expand into this new frontier, the inquiries will continue to grow, and so will the discoveries. The LHC has a long way to go from its beginning, and with each experiment, we are one step closer to understanding the deepest mysteries of the universe. While the path ahead may be unclear, the possibilities for discovery are endless, and the search for that information may be one of the most important endeavors humanity can undertake. As the Large Hadron Collider LHC continues its groundbreaking work, it also raises questions that extend beyond the realm of pure science. While the potential for breakthroughs in particle physics, cosmology, and quantum mechanics is immense, the ethical implications of these tests are becoming more apparent. As humanity pushes the boundaries of knowledge, the moral responsibilities of those researching with such high stakes cannot be ignored. The LHC investigates the universe in its purest form, but it also presents us with inquiries regarding our part in the cosmos. In a sense, the LHC represents cutting-edge research in science. It embodies humanity's insatiable curiosity and longing to conquer the unknown. It also brings to light a significant paradox, the same tool that could answer the most profound questions about the universe's origins may also contribute to unintended consequences. The tension between discovery and risk is not new, but the scale and ambition of the LHC make these concerns particularly pressing. The LHC's experiments are based on the principle that by understanding matter's fundamental components, we can learn more about the forces that govern the universe. However, these experiments delve into realms of physics that test even the most reputable theories. The creation of microscopic black holes, for instance, provides a paradox. In contrast to what theoretical models predict, their rapid evaporation through Hawking radiation is merely conceptual, meaning there are still uncertainties. Could these tiny black holes behave differently than anticipated, potentially leading to consequences as unanticipated as the LHC investigates phenomena like dark matter and the Higgs boson? It also opens doors to the possibility of gaining new knowledge about unknown forces of nature. The discovery of these unknown forces could alter our lives forever. However, the potential dangers of unlocking such forces could result in destabilizing existing structures of spacetime or even creating environments that defy the laws of physics as we know them. While scientists maintain their faith in the safety of the experiments, the possibility of the unexpected continues to overshadow the legacy left by the LHC. In light of these risks, one might wonder whether continuing to conduct experiments that could alter the fundamental laws of nature is responsible. However, it is essential to recognize that scientific progress is often achieved through exploration into the unknown. History is full of examples where the pursuit of knowledge has resulted in both positive and negative consequences. Nevertheless, progress was eventually made. With the LHC, the benefits of discovery may far outweigh the risks, provided that ethical behavior and security measures are followed. At the heart of this debate lies a fundamental question: is humanity prepared to confront the potential negative effects of its own curiosity? As scientists continue to explore the deepest mysteries of the universe, they must strike a balance between the pursuit of understanding and knowledge of the broader implications of their work. The LHC is more than just a tool for scientific advancement. It serves as a reminder of the responsibility that comes with exploring the unknown. It calls upon humanity to consider not just what we can discover, but what we are.